Hello and welcome to the Introduction to Industrial Ergonomics Training Module. Many people think of office ergonomics when someone mentions ergonomics, but our working group is here to inform people that ergonomics goes beyond the office environment and cubicle land. Ergonomics has the ability to affect a person's body in the office, doing industrial work, and even outside of work, at places like home or when doing recreational hobbies. In this training module, we hope to define ergonomics, identify ergonomic risk factors, and discuss potential options for intervention. Please note that there are an additional 4 training modules that go into more details regarding ergonomic hazards. These modules cover topics on ergonomic risk factors in various types of workshops, on our navigable waterways, out in the fields with our rangers, and for anyone doing material handling type tasks. The technical definition for ergonomics involves the application of knowledge about human capacities and limitations to the design of workplaces, jobs, tasks, tools, equipment, activities, and the environment. But the simpler definition for ergonomics is fitting the workplace to the worker. Musculoskeletal disorders are injuries and disorders that affect the human body's movements or muscles, tendons, ligaments, nerves, and other various soft tissues. Cumulative trauma disorders occur when there is an excessive wear and tear on tendons, muscles, and sensitive nerve tissue caused by continuous use over an extended period of time. Cumulative trauma disorders, or CTDs for short, they are typically a result of repetition, force, or improper work positions.
Can you see the benefits of an ergonomic intervention? It should be obvious that the creeper will help do this job faster, easier, and with less strain to the body. What was provided? What benefits to the worker do you see? Benefits to the worker include a padded surface for his back, insulation from the ground, improved back, shoulder, and neck, and arm posture ergonomics. Can you see the benefits of an ergonomic intervention? It should be obvious that the employee is able to stand upright while maneuvering the cable. This will require less work from the employee and reduce material handling and trip hazards. What was provided? What benefits to the worker do you see? The worker is less likely to hurt his back while pulling the cable. This task should be easier and faster for the employee to complete. Why do we care about ergonomics? We care about ergonomics because poor ergonomics can lead to debilitating musculoskeletal disorders and injuries that have the ability to impact daily life and routines as people age. What are some of your favorite hobbies? What can you lose? USACE cares about ergonomics for multiple reasons. One reason we care is because the Industrial Ergonomics High Hazard Working Group reviewed all of the reported accidents from FY12 through FY14 and found that almost a quarter of our reported injuries were related to ergonomic hazards. We also found out that we have 32 ergonomic-related injuries in the industrial environment annually. Additionally, the Corps of Engineers pays out $21 million annually in workers' compensation costs for all ergonomic injuries. That's a lot of wasted tax dollars for preventable injuries.
We as an organization and you as an employee should care about ergonomics for multiple reasons. First and foremost, it is pain and discomfort you can experience later in life from MSDs and CTDs. Other intermediate proactive reasons for learning about ergonomic risk factors. Our personnel can experience increased pain during activity which can lead to discomfort, decreased productivity, and decreased morale. Ergonomic injuries hurt the individual because the employee will need to take time off from work to attend doctor appointments, physical therapy, and possibly participate in avoidable, painful, costly surgeries. The employee may experience a reduced rate of pay from workers' compensation and disability. The organization and team has to deal with increased workload, absence of teammates, and the increased cost of finding a replacement worker. These are all challenges that employees, employers, and supervisors face when an employee becomes symptomatic and then suffers an injury. Ergonomic risk factors exist both at work and at home. It is important to apply the concepts you learn from this module during your task at work, while playing, and working at home for the greatest benefit. Practice good ergonomic principles every time you identify a risk factor. Speaking of risk factors, over the next several slides, we will identify and define each risk factor. There are 7 risk factors for MSDs. The top 3 risk factors are force, posture, and repetition. Often, workers are exposed to multiple risk factors. Understanding the risk factors will make ergonomics more applicable to you. Duration is defined as the length of time performing a task. General guidelines for duration length are short duration, less than 1 hour, moderate duration, 1 to 2 hours, long duration, greater than 2 hours. As you can see, any task over 2 hours places you in the long duration category. This is troublesome if the daily repair of muscles, tendons, ligaments, and nerves cannot occur.
In short, you should be aware of how long you are doing something. Is it 10 minutes at a time, an hour at a time? The bottom line is that the longer the duration of the task, the greater the exposure and the greater the risk. It is recommended that you take frequent short breaks instead of occasional long breaks, so the body has time to move, be in a different position, and recover. Who's familiar with these items? Many people use smartphone technology for work and fun. It's easy for users to lose track of time while reading emails, surfing the web, and playing games. It's also easy for users to not be aware of static body positions and awkward postures for long periods of time. When using handheld electronic devices, users should be conscious of body posture and limit the amount of time on handheld devices. Handheld devices may lead to a phenomenon ergonomists call tech neck. If we are not aware of the amount of time we spend with our heads down looking at our handheld electronics. The next risk factor is compression, which is also known as mechanical compression or contact stress. In short, any outside object coming in contact with the body causes compression. Items such as hard edges, sharp surfaces, corners, and excessive weight can cause damage to the body's soft tissue. An everyday example of compression is the plastic shopping bags we use when checking out of the supermarket. Place 1 or 2 gallons of milk in the bag and then lift by the handles. The shopping bags dig into your fingers. That is compression to the fingers. Can you think of any tools or work activities that cause the described scenario? Where do you see compression in the photo of the person typing? There is compression on the fingertips when they touch the keys. There is also compression from the watch and the ring as well. Rule of thumb for jewelry is jewelry should move freely on the wrist. If you take the item off and it leaves a perfect imprint on your skin, then the item is being worn too tightly. The ring on the finger should spin freely around the finger. When do you see compression in the photo of the person carrying the ammunition? Although the missile has rounded edges, the weight of it can still cause problems to the people lifting it. Where is the mechanical stress here? The answer is in the shoulder.
Posture, otherwise known as position, dictates how hard the body works. The goal of the ergonomist is to keep the joints in zero-deviated positions. The easiest way to accomplish this is to keep workers from bending, twisting, and reaching. Also, make sure workers have some movement as part of their job to avoid static loading on the body. You can see the helpful tips in maintaining a neutral posture. When standing in a neutral posture, the head is above the shoulders, which are above the hips, and the feet. The upper arms are relaxed and close to the torso. The seated neutral posture has many similarities as the standing neutral posture. Here's a picture of a man fixing a component over his head. What body parts are in a non-neutral posture? There are 4, his neck, shoulders, arms, and legs. Now why do you think he's working like this? This gentleman may have decided this is to be a quick task and determined it would take more time to figure out how to position the work between the shoulders and waist, so he may work in a neutral position. Each time you work in a non-neutral posture, you're putting additional stress on your muscles, tendons, ligaments, and nerves. The next risk factor is vibration. As you see, we are concerned with vibration as it can cause injury due to interference of blood flow as well as mechanical trauma to the body. Our goal as ergonomists is to eliminate or minimize vibration exposure.
Segmental vibration affects different parts of the body. The most common type of segmental vibration is hand-arm, which is usually caused by workers holding vibration hand tools for a long period of time. This action causes reduced blood flow to the fingers, and can lead to blanching of the fingers. Other risk factors present in this picture are posture, wrist, neck, and shoulder, force, repetition, and most likely duration to the hands and arms. Whole body vibration is caused by standing, sitting, or vibrating surfaces. The vibration works its way through the body and results in muscle fatigue and contractions. Note the boat operators are exposed to whole body vibration when they drive. Our work patrolling the waterways is a source of vibration exposure. One way to reduce exposure to vibration is by using shock-absorbing seats. Force is the next risk factor we will discuss. By definition, force involves the use of power or exertion. Common forceful activities include pushing, pulling, lifting heavy objects, using hand tools, or using fingers to shape or finish materials. These are guidelines which come from the Navy document, Naval Operation Instructions, Appendix A. Checklist regarding heavy lifting. Forceful exertion is defined by lifting more than 25 pounds from a height below the knees or above the shoulders or at arm's length. It includes lifting 75 pounds at any one time. Pushing or pulling with more than 20 pounds of initial force is also classified as forceful lifting. Strength varies by person, and as an individual we offer difference in tolerance and ability. The strength to lift, physical endurance to say roll a boat, and the strength to maintain a static posture are all personal attributes. The best idea is to lift heavy items by using mechanical means or asking for help. The definition of excessive hand force is either gripping with more than 10 pounds of force or pinching objects with more than 4 pounds of force. This force equates to the amount of effort it takes to squeeze two wooden clothespins together.
Another risk factor we'll cover is repetition. Repetition, or use of the same body parts continuously throughout the workday, is damaging to the body. Microtraumas from repetition can result in inflammation of the tendons, muscle irritation or entrapment syndrome, and nerve irritation. Prolonged exposure to repetitive motions can result in even more traumatic injuries. This employee, at one of our projects, made approximately 150 of these discs. Each disc required 6 different cuts from the lathe, and he was responsible for programming each one of the cuts into the machine and positioning each disc. Here is a video of the USACE mat sinking unit, which is used to lay concrete on the bottom of the Mississippi River every year. Take a look at these guys. There's obviously force and compression issues related to handling those metal rods to position and stabilize the concrete blocks, not to mention repetition. One recommended solution is to rotate each crew member through each task every hour so muscle groups have a chance to rest. The next risk factor is cold temperature. Cold temperature reduces blood flow throughout the body and decreases tactile feedback. Reduced blood flow minimizes the nutrients that travel to the muscles. Reduced tactile feedback will cause the hands to work harder than they have to. For example, imagine changing a tire in cold weather with no gloves. True or false? Ergonomics involves the application of knowledge about human capacities and limitations to the design of workplaces, jobs, tasks, tools, equipment, and the environment. If you said true, you would be correct. What is another way of defining ergonomics? If you said fitting the workplace to the worker, you would be correct.
Why should employees care about ergonomics? If you said all of the above, you would be correct. Where should ergonomics be applied? If you said everywhere, you would be correct. How many work-related musculoskeletal disorder risk factors are there? If you said 7, you would be correct. What are the 7 work-related musculoskeletal disorder risk factors? If you said repetition, vibration, duration, posture, compression, contact stress, force, cold temps, you would be correct. Which of the following work-related musculoskeletal disorder risk factors is defined as the length of time at performing a task? If you said duration, you would be correct. The work-related musculoskeletal disorder risk factor repetition is defined as using the same body part continuously throughout the work period is the correct answer. Which of the following WMSD risk factors is defined as a particular joint at zero deviation? If you said posture, you would be correct. The WMSD risk factor vibration is defined as oscillation of a mass around a reference point.
Now that you have learned about the risk factors for ergonomic injuries, let's look at strategies to control work-related musculoskeletal disorder risk factors. Strategies include engineering controls, administrative controls, quick fix solutions, and job process improvements. Each will be discussed in more detail. Engineering controls are physical changes to the workstation. The benefit is their effectiveness. The downside is they require money to be spent. Administrative controls do not change the workplace, but rather how the work is done by workers. For example, instead of making 5 50-pound lifts, the worker makes 10 25-pound lifts or has a coworker help with the lift. In the picture at the right, a team lift is taking place. Do you think it is still possible to get injured while team lifting? It is likely for a person to get injured during a team lift. Sometimes body sizes and capabilities are not matched well, and one person can take on a larger part of the load. This can lead to an injury. Use of the quick fix is an inexpensive way to improve jobs at your location. Here we see an example of a fan getting relocated. This was a no-cost solution, took less than an hour to complete, and resulted in a time and manpower savings when it needed to be taken and replaced.
Here is another example of a quick fix. Sometimes tools that create a lot of compression may have padding taped around the handles. The better solution obviously is to purchase hand tools with cushions on the handles, but sometimes resources will not always allow for tool replacement immediately. The one thing you want to be careful about is that you do not create other hazards when you are implementing quick fix solutions. We recommend talking to your supervisor or local safety and occupational health office for advice on quick fixes. Job improvement process is a method to document complicated tasks and improve expensive equipment that is not likely to be replaced in the near future. Here are a few knowledge check questions. Which of the following is an intervention technique that can be used to minimize or eliminate the ergonomic risks? If you said all the above, you would be correct. What intervention technique improves workstations or environments by identifying tasks, processes, and jobs that can be improved rapidly and inexpensively? If you said quick fix solutions, you would be correct. What intervention technique makes physical changes to the workstation? Is typically the most effective in eliminating the risk and with the goal of equipment doing the work and the worker operating the equipment? If you said engineering controls, you you would be correct. What intervention technique typically has no cost? Changes work assignment or scheduling, is moderately effective in attempts to reduce magnitude, frequency, or duration of work? If you said administrative controls, you would be correct.
What intervention technique is a method to document complicated tasks and improve expensive equipment that is not likely to be replaced in the near future? And the goal is not to make the same mistake when replacing the equipment or when redesigning the task. If you said job process improvement, you would be correct. To review the main points we have discussed during this training session, please remember ergonomics is about fitting the workplace to the worker, not the worker to the workplace. Ergonomics is important because it decreases your risk of developing work-related musculoskeletal disorders and improves efficiency. There are 7 risk factors which will be reviewed on the following slide. Additionally, there are 4 types of controls. All have their advantages, disadvantages, and usefulness in various situations. Again, here are the 7 risk factors associated with WMSD injuries listed in an acrostic sequence. Just remember, Diet Coke provides vitality for thirsty runners. Also remember the 3 most common risk factors are repetition, posture, and force. We hope you find this presentation to be beneficial. If you have any further ergonomic questions or concern, please contact your local safety office.